There we go. Okay. Okay, this rule, can someone get the lights please? This rule is called the chain rule. And the chain rule in essence is dealing with a derivative within a derivative within a derivative. Okay? Now, let's look at problem number one. Number one wants you to, they don't want you to take the derivative yet, they just want you to recognize that there is a function within a function. So on number one you have y equals to 5x minus 8 to the fourth power. So what they want you to recognize is that this is a function on its own. In other words, if you look at the column right here, they would want you to put u would equal to 5x minus 8. You see? So y equals to f of u. That's all. Now, that might be important, might not, I'm not sure. But for us, a more practical approach would be, okay, how do we take the derivative of something like this? You're not going to multiply 5x minus 8, 5x minus 8, 5x minus 8, 5x minus 8. That would be ridiculous. That would be the product rule, you know, how many times, it makes no sense. So we need to approach this in a very practical way, and that's where the chain rule comes about. Well, the chain rule is like this. It says, if y equals to, let's say, f, and then of g of x, right? There's another function inside f of x. There's something else inside f of x. What you do is, to take the derivative with respect to x, you take the derivative of f, and you leave g of x there. You leave g of x as it is, you leave it alone. Then you're going to multiply by the derivative of g of x. That's the rule. Okay? So in other words, it would be the derivative of f, leave g of x alone, times the derivative of g of x. In other words, the derivative of the inside function. That's the formula. So, if we look at this problem, if we go back and we look at the first one, y equals to 5x minus 8 to the fourth, watch what's going to happen here. We take the derivative of the outer one, which is what? We just pretend this is like some big old x. What's the derivative of x to the fourth power? 4x to the third. So 4x to the third, right? Yes. Well, see, according to the formula it says leave g of x alone. So you don't change that. But then over here on the side we multiply by what? The derivative, which is what? 5. So our answer would be 20 times 5x minus 8 to the third. That's the correct way. Alone. In other words, look, let me go kindergarten level. Y equals to, let's say inside, let me put it like this, inside to the 99th power. Okay? So it would be y prime equals to 99, leave the inside alone, to the 98th, times the derivative of inside. In other words, the derivative of the inside. That's the way it works.
Alright.
Okay? Let me show you a practical example now with, let's say, I'm going to go around those same lines. Let's say sine x plus e to the x raised to the 900, something ridiculous like this, 999. You're not going to sit there and multiply that 999 times. If you do that, that's your exit ticket out. Bye. See you later. Now, what would be the way to tackle this according to the formula? 99. You leave, what do we do?
Leave it alone.
Leave it alone. And then what do we put up here?
93.
And then, yeah, we're done.
No, time.
Excellent.
Cosine plus E.
Very good, Marisabel. You're live on camera. You're doing excellent. And that's it. Now, what you do after that, I mean, let's leave it like that. That way we recognize what we're doing. Let me show you, I usually don't do this. Let me show you the most common mistake people make. And I've been doing this for about 18 years, so I think I know more or less what people do over time. This is the most common mistake. This is the way to take the derivative. You know, like those commercials where they show you, don't do this. This is what people do. What did they do wrong?
They didn't leave it alone.
They didn't leave it alone. They wanted to do everything at once. But I'm taking the derivative. Yes. I don't know what you're doing. You're creating your own system of something.
Okay.
And guess what? They'll put that, if it's on a multiple choice format, they'll always put that answer. And about 60-70% fall for it. Like you said, what was the word that you used? I like that word. They didn't leave the inside alone. It's like, leave it alone, then you take the derivative of it. That's the most common mistake I've seen. Absolutely incorrect. Okay. Let's look at an example where I'm going to make up one. Let's say the square root of x squared plus e to the x. Square root of e to the x. You might say, how in the world would that? I use the chain rule in something like this. Well, first of all, the square root here, x squared plus e to the x. Start writing that as the half power.
If it's e squared inside the square root, wouldn't that just be
You can't take the square here. In order to take the square root of a number, it has to be a single number. You cannot take the square root of a sum. Like that, you just leave it like that. Okay? Now, y prime would be, this is your inside, leave it alone. So what would we do? Bring the half down.
to the front?
Okay, so that becomes half, leave the inside alone, leave the inside alone, repeat it, you know, on the way to school in the morning, leave the inside alone, leave the inside alone, and then 1/2 minus 1 is negative half. Okay, now times the derivative of the inside. What's the derivative of the inside? Excellent, excellent, excellent. So we get 2x plus e to the x. I'm going to simplify it. Look, watch. This 2, I'm going to put it down here. And then, since this was negative 1/2, where am I going to write that square root? On the bottom. Maria Isabel, you're on fire today. Hope it's Halloween every weekend. Okay. Any questions?
Why did you put it like in practice? Like, because
This is negative 1/2 means it goes on the bottom.
so it becomes positive. Yes.
Is that clear? Let's see. just getting so much fun, you know. Let me give you one to practice. Y equals to the cube root of cosecant x plus pi x squared. Okay? Before you even begin anything, you're going to want to what? And what would you rewrite this as? There you go. Now go ahead. See it as like x to the 1/3 power, something like that. Go ahead and try it, please. If you're at home and you're following along, you try it as well too. Mr. Connor and Miss Connor, Miss Buchanan, Mr. Perez, Mr. Schlater. Warm greetings from South Texas. Well, it'll be recorded. And maybe you, Mr. Leal, you want to go back online tonight and review this with a little bag of popcorn? Greetings from South Texas. There they are, hard at work. Sorry they're upside down, but they're there. Okay, so what do we get? Okay, so first, let's one step at a time. 1/3 x plus pi x squared to the what? -2/3 times what? Plus pi x. Now let's rewrite that. We would rewrite that as, obviously going to be a denominator. The 3 will go there for sure. And the numerator would be negative cosecant x cotangent x plus 2 pi x. On the bottom, it is a cube root, so you can put the cube root inside like that. And then you just put cosecant x plus pi x squared raised to the what power? Raised to the power of 2, because here it has the 2 there. And that's it. Questions? Yes, sir.
For the 2/3, like, don't you multiply 2 times 3 into the
No, 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 no. Because this is a power.
Okay.
This is an actual numerical value. And the power is right here. 2/3, see? The negative just moves the expression to the denominator. Are we good? Okay. Yes.
What does that do, like,
Up to 19.
okay.
Okay, let me explain the difference between sine x squared and sine squared x. Have you ever wondered what the difference is? Right. On one of them, in other words, on one of them we have y equals to sine. We're actually squaring the x. On the second one, when it says sine squared x, this actually means there's two sine x's, or you could say 2 as an exponent, and you could put sine x like that. That's the difference. In both cases, you would apply the chain rule to find the derivative. To find the derivative of this expression, dy dx, it would be, what's the derivative of sine? Cosine. So we leave the x squared alone. Times, what's the derivative of the inside? What's the derivative of x squared? So I can rewrite my final answer as 2x cosine x squared. You all see that?
Yes.
On this second example, look at the difference. Now sine x is inside, so we bring the 2 down. So this would be 2 sine x to the what? Sorry, this is dy dx. To the first power. We usually don't write it, but putting it there just for clarity. Times the derivative of the inside. What's the inside? And what's the derivative of sine x? So the answer would be 2 sine x cosine x. You see the difference? Very big difference.
Wow.
Isn't this an identity? That would be... Do y'all remember that identity? No. Uh-huh. Very good. Great job. Filizola's watch. Dr. Filizola's watching this, and she's just jumping up and down, so proud that you remembered this. Is that it? 18 minutes?